we are starting 7.4. Now, if you recall, 7.3 was multiplication properties of exponents. So any guesses what 7.4 is? Division. Division properties of exponents. All right. So I might as well give you the rule to start with, right? Then we'll talk about what the rule really means. Okay, so if I have x raised to the m divided by x raised to the n, so I have the same base. Technically what they want you to do is you're going to keep the base and subtract your exponents. Okay, that's what the rule says. Now, for example, if I had x to the fourth over x to the second, technically the rule says we're going to take x and go 4 minus 2, so my answer is x squared. The reason this works is because x to the fourth means I have 4 x's all multiplied together, divided by. On the bottom, I have x squared, or 2 x's. So then I can cancel any of the same factors. So what does that leave me with? Yeah, x squared. That's why it works. You should have done it. You did it in Math 8, yes. Okay. All right, so now there are other ways that you're going to find that I say this, however. When you look at this original problem, one of the things I'm going to say to you is, where are there more x's? You're going to tell me, in this case, on the top, right? How many more are there? 2. Okay? That's how I want to look at it. The reason I'm going to say it that way is, what if we had something like this? X to the third divided by x to the seventh. If we did it by the rule, we would take our base and subtract our exponents. So we get x to the negative 4. And then what would we have to do with that? Move it to the bottom. However, if I just say to you, where are there more x's? On the bottom. So I'm going to put my x on the bottom, and how many more are there? There are 4. We're done. Okay? All right, so this is our general idea of what we're doing today. Any questions with it right now? Awesome. Here we go with example number 1. Uh-huh. All right, so I'm going to ask you to simplify. Let's say I have b to the 7th over b to the 2nd. I can subtract my exponents, or I can say, where do I have more b's? On the top. So that's where I put my b. How many more do I have? 5, and I'm all done. So obviously we can step this up a little bit, right? Hello? Okay. Yep, bye. I don't want to forget to do that. Okay. All right, let's try one like this. What if I had x to the 3rd, y to the 7th over x to the 5th, y to the 2nd. All right, so we're going to start with our first bases that are the same. We're going to start with our x's. Where do I have more x's? On the bottom. How many more do I have? 2. Excellent. Now let's do our y's. Where are there more y's? On the top. How many more y's do I have? There you go. Perfect. All right, so let's go to example number 2 then. Example 2. All right, so we're going to add in a couple more rules. This is going to take you your 12 through 22 in your homework today. It's going to ask you to simplify the expression. So simplifying the expression, let's start off with, how about x to the third y to the negative 2 over x y to the negative 5. All right, so we can't really tell where we have more of anything yet. We have to get rid of those negative exponents. So what do you think we should do? Perfect. So that would be step number 1. This one's going to go down there, and this one's going to go up here. So I have x to the third, y to the 5th, over xy squared. All right. Now we're going to start with our x's. Where do I have more x's? On the top. How many more do I have, Jackson? 2. Good. Where do I have more y's? On the top. How many more do we have? We are done. Okay, so I'm saying that to you, but you should be asking yourself that as we do them, right? Okay, let's try another one. What haven't I added in yet? Numbers, coefficients. Let's put some coefficients in here. Let's say I have 4. A to the third, b to the 0 over, how about 6, a to the 5th. All right. Let's start with our numbers. I want you to start by reducing or simplifying that fraction. 4 over 6 reduces to 2 over 3. Awesome. All right, now we're going to go to our next one in line. We have our a's. Where are there more a's? On the bottom. How many more do we have, Madison? 2. Good. And then tell me about b to the 0. It's 1, so I can just cancel that. 1 times anything is still where I'm at, right? All right. That's our answer. We're done. I hope so. Let's do one more. Let's go. C to the 5th, d to the negative 2 over c to the 2nd, d to the 5th. All right. We want to move that negative exponent, right? He's got to go down to the bottom. So I'm going to move him down here, but there's already some down there. What do you think we're going to do? Add them together. Very good. So we're going to have c to the 5th over c squared d to the 7th. We have to add those 2 to the 5 that are already there. All right, now what do we need to simplify? C. Where are there more c's? On the top. How many more are there? 3. And do I have anything to cancel my d's with? We're just going to stay put. Any questions? Okay, so first you would simplify numbers, and then work on your variables alphabetically. All right? Okay, that's the first section. Are we ready to try the next section? Example number 3. Actually, before I do example number 3, talk about scientific notation. All right. When we're doing scientific notation and we're doing the division, I want you to first, step 1, divide coefficients. Step 2, keep base 10 And subtract exponents. Step 3. Be sure coefficient is between 1 and 10. All right, so an example of this. If I had, let's say, 3 times 10 to the 4th divided by 9 times 10 to the 7th. Step 1 says divide your coefficient. So we're going to divide 3 divided by 9. 1/3, but what is that as a decimal? 0.3 repeating, right? I'm going to go out like 3 places. Okay? Times 10, I keep my base, and what do I do with my exponent? Subtract them, right? 4 minus 7 is -3. Then, looking at your coefficient, is that between 1 and 10? Too big or too small? Too small, which means I'm going to subtract from my exponent however many I have to move my decimal place. This, I'm just moving it 1. So I get 3.33 times 10. I moved it 1, so -3 minus 1 is -4. Okay? All right, so we're going to do example number 3. Example number 3 is going to cover 24 through 32. All right, let's go with, how about 3.5 times 10 to the 7th divided by 5 times 10 to the 2nd. All right, very first thing we have to do is divide our coefficients. We're going to start right here. Divide your coefficients. 3.5 divided by 5. 0.7. Very good. Times. I keep my base at 10. I subtract my exponent. 7 minus 2 is 5. Then I look at my leading coefficient. Is it between 1 and 10? Too big or too small? Too small means I'm going to subtract. I have to move it over 1. So I get 7 times 10 to the 4th. All right, so I'm going to do one more scientific notation before we go on to the last section today. Okay? One more. Let's say I have 49 times, how about 4.9 times 10 to the -3 divided by 7 times 10 to the -5. All right, so first we divide our coefficients. 4.9 divided by 7? 0.7, very good. Times 10. Now, here's why I did this one. This is a little tricky. Remember, I'm subtracting my exponents. It's -3 minus a -5. It is +2. So I wrote it down so you can see it, right? We have a sandwich going on here. So we really have -3 plus 5, so we get 2. Is that leading coefficient too big, too small, or just right? Too small. So I'm going to subtract from my exponent. I'm going to move this over 1. So I have 7 times 10, 2 minus 1 to the first power. Any question on the scientific notation? No? Okay. It's not. This is scientific notation, though. That's just, yeah. I get why you're saying, but the reason I do scientific notation is, yeah, so you're getting to, it's a way of not having to write down something that's like 13, 14, 20 digits, whatever, right? Yeah. All right, last thing I want to talk about. Last rule we have to deal with is division can also be written as a fraction, right? So if I have inside, let's say I have x over y inside a parenthesis. And then I have an exponent outside the parenthesis. My rule says that you can take this exponent and give it to everything on the inside. So this just becomes x to the third over y to the third. I'm going to throw one more little wrench in that little rule. If I have x over y raised to the negative 3, we can do this one of two ways, and you guys are going to tell me which way you would prefer to do it. Way number one is you give this negative exponent to everything on the inside. So you get x to the negative 3 over y to the negative 3. Then what would we have to do? Flip it, exactly. So this becomes y to the third over x to the third. That's the first option. Second option is because it's a negative exponent, we can flip what's inside our parenthesis first and make it y over x and change my exponent to a positive. Then I can give that positive 3 to everything on the inside. Say it y to the third over x to the third. It is pretty much the same thing. I agree. It's just which way you want to think about it. Okay? All right. So our last section is all about having these fractions in parentheses and how we simplify it. All right. So example number 4. Example number 4 is going to cover your 34 through 48. That's a few more problems than normal. 4 more. Well, actually, only 3 more than normal. But all right, so let's do something as easy as how about 2x to the third over 3 all raised to the third power. All right, so this 3 on the outside, I have to give it to everything on the inside. That means I'm going to have 2 to the third, x to the third raised to the third. What do I do with those exponents? Times them. Good. Over 3 to the third. Now we got to simplify those numbers, right? 2 times 2 times 2 is 8. X to the 9th. Over 3 times 3 times 3, which is 27. Good. Not too bad. All right. Last one then. Let's say I have x to the fourth, y to the second, over x to the third, y to the fifth, all raised to the -2 power. All right, so here's what I'm going to say to you. Order of operations tells us we should start where? Inside the parenthesis, right? So can we simplify inside that parenthesis first? All right, so let's start inside the parentheses. I'm going to put my parenthesis there, raised to -2. First of all, where do I have more x's? On the top. So I'm going to put my x there. How many more do I have? Just one. Very good. Okay, where do I have more y's? On the bottom, how many more do I have? 3. So this is a lot easier to work with than what this first one looked like, right? Okay. So now, which way do you guys want to do it? Do you want to flip it first and make our 2 positive, or just distribute the -2 to everything and flip it afterward? The second one? First one? Whichever. I can pick. Okay, well then I'll distribute it. We're going to take this -2 to x to the first, and the -2 to the y to the third. So that's going to give me x to the -2 over y, and remember we're going to multiply those exponents. 3 times -2, -6. Then I have to move this one to the top and this one to the bottom. So y to the 6th over x to the 2nd. All right, what do you guys think? Any questions? All right, so I am going to, let's do only to 42. Okay? All right, just to 42. So I'm going to change that to 12 to 42.